Good afternoon, everyone. Can you hear me okay? Great. Thank you so much for coming. We're so excited to be here. My name is Lynn Recker. I am the science and STEM teacher and science chair for Memphis Academy of Science and Engineering in downtown Memphis. So, do we have any Memphis people here? No? Nashville people? Knoxville? Oh, okay. Hey, all right. We got some of our hometown people. Welcome all. We're glad that you're here today. I'm going to go a little bit fast. And the reason why is, well, one, I don't want to bore you to death. And two, we're going to just kind of touch base on the project piece of it and let you get into the hands-on part. Before we get started, let me make sure I know how to do this. Look at that. It works. Okay, so this is the agenda. We're going to touch base quickly on the strategies that why we're even here, right? So I'm not going to talk a whole lot to teachers and administrators about project-based learning because I think everybody here knows how to do that, right? Good. Okay, so we're going to talk about that and how to infuse computer science education with that. Today you're going to experience high impact cross-curricular instructional strategies through project-based learning, and I'm going to show you what I did with the TSENS engineering design process, design challenge, I'm sorry. Did anybody in here participate? No? Okay. That's okay. Well, what we did is we gave the students a problem, and I used the design challenge, and it was the first time I've ever done it. I said, okay, let's give it a try. So we looked at the environmental problems of the city of Memphis. And what I found was I didn't know a whole lot about my own city. And I think I learned more than the kids did when it was all said and done. Through that, we also infused the Ozobots. And at the end of this session today, I'm going to show you a resource where you can actually get them yourself for free. You like free, right? Yes. Okay. Okay, so through TSEN and all the things that I've learned with working with that organization, they always start with the why. Why are we doing it? Well, of course, you probably know by now that the bill has passed and the computer science integration is now something that we have to embed in the curriculum. So with that said, I'm going to show you how to integrate and use the Ozobots to help do that. We also have a quick survey, correct? And I think if I go to the next slide, it might show that. No? Let me go back. Okay, if you can, scan that really quick. Are you getting it to work? Does it work? Good. Okay, so Mr. Cooley and Miss Williams are here also. I've got the dream team with me. And are you able to look at the data from what they just submitted with the poll? So what we want to know is who has some experience or any with the Ozobots. And the results are coming in. Drum roll.
Okay, so 70% do not have experience with Ozobots and 29% do.
Perfect. So 70% of this group does not have experience with Ozobots. That's exactly what we need, right? Because we need someone to show us. And the difference does, as you said. Is that correct? Okay. Okay, so why Ozobots? Well, our school was selected to be part of the computer science pilot, And the state, they chose, total, it was originally 9, but I think it's down to 5 now. 5 schools to serve as a model. And so I applied for it, we got it, and I thought, okay, great. Now what do? I know nothing about computer science, just being honest. I mean, I know a little bit. I know how to create a PowerPoint, of course, and Excel and all that stuff. But how do I teach kids how to code when I don't know how to code myself? So I did a little digging, and I'm going to share with you what I found. Before I get to that, I want to show you the design challenge that we participated in, and I was really shocked. I knew it was good, but I didn't know it was that good. So we won the region. We didn't win the state, but we did win the region. So instead of me telling you all about it, I'm going to show you the video that I submitted and let you check out. This is just a project piece. Let me see. You may have to do it from the back. This is the video. Hello, this is Miss Recker from Memphis Academy of Science and Engineering. I am creating this video to share with you in lieu of the presentations for the students, as we had a technical issue. So I'm going to send this for now, and they'll be sending the presentations on Monday when they resume from spring break. So we had a lot of great projects. As you can see, we did build a model of our city, and this is just a portion of it. We're also using Ozobots to guide the tour, and the students will show you that more in detail soon. So we had a lot of great builds. First, we have Walmart. And as you can see, the students created the model as well as part of their solution, which was to grow their own produce in-house to sell. And they also identified another problem, which was parking lot runoff. And I didn't realize that was such a problem, and that's what the attachment is at the top on the roof. That is to collect rainwater and disperse it into a location that does not go back into our groundwater supply. So Walmart did a great job. The next one we'll look at is Amazon. And this was a great build. The students actually used wind turbines, and it has working electricity. They will model that to you again on Monday. They also identified that getting rid of packaging waste is a huge problem for Amazon. So they believe that we can use robots to design a way to improve that. The next problem was with Aspire Elementary. And the students researched and found out that Aspire had a huge problem with lead in their water supply, and that their preschool students were actually consuming that water. So the solution was to change the pipes to non-leaded pipes, and they'll talk more in depth with you about that when they do their presentations. Okay, and last is the drip irrigation system. This student identified the problem as overusing water and trying to help increase agricultural sustainability. And they also noticed that irrigation causes increased water evaporation, which impacts surface air temperature and pressure, as well as atmospheric moisture conditions. So we grew the plants. Lily, actually, I gave her this drawer. I think you can see the handle on that far side. She repurposed the drawer. She created an agricultural area. We sowed seeds, many kinds, but the ones that stand out the most is the purple coneflower, which is actually on the endangered species list. And it also, these type of flowers really promote bee populations. So that's a win-win. So with Lily's design, she created the drip irrigation system so that the water would be delivered directly to the root zone of the plant. And rather than wasting the water, it's actually going to the plant instead of just being evaporated. So let's test out her design. Okay, got the water going. It's flowing well, and you can see it's being delivered to the plants. And that is a really cool build. Everything that she used except for the tubing and of course the soil and the seeds have been repurposed down to the water tower. Those were all supplies that we have used before, and we reused them. She identified the careers as well, and her build is definitely working. So thank you for being so helpful. We look forward to sending the presentations to you from the students on Monday, and we look forward to sharing even more of our build with you. Okay, so that was just the top four, and I'm going to show you a couple pictures in just a minute of the whole city. So the kids came up with the problems. They decided what they wanted to research. Then they identified the solution. We used Tinkercad. We did 3D printing. They actually printed pieces of the pipe, the before and the after. We learned so much. I promise, if you haven't tried to do this yourself, I would seriously encourage you. It doesn't matter what content area you teach. There's so much that you can learn from your own city, and it seems like the students were more connected once they knew. Well, hey, I know somebody that goes to Aspire, or I'm worried about the water supply in Memphis. So making those connections were key. So that's the project-based part. Like I said, I'm not going to bore you too much with that. I mean, we're all teachers, or maybe you were, and you're certainly competent in that area. Now I'm going to show you how we plugged in the bots. So after we got the design all started, I got the Ozobots. I actually borrowed them. Our school does not own any. And I reached out to an organization. I'll share that with you at the end. And they loaned them to me. When we first started, I will be honest with you, I had no clue what an Ozobot even was. I just thought it sounded cool. I researched it. Thought, okay, let's give it a try, because we're trying to move towards teaching our kids to be ready for this new bill to go into effect with computer science. So this clip's really short, and I won't give you any more after that. Well, not for a minute anyway. So the second clip is what our students programmed the bot to come to. It went through the city, our little city, and it identified an environmental problem. And when it did, he had it programmed so that it would flash red when it had an environmental problem and green when it found a solution. So that will be the second video on the right. I'll attempt to do it again, and if it doesn't work, I have to have some help from the back.
This computer's not signed into your Google Drive. It won't let me in.
It won't? Okay. Okay, we'll move forward, and we'll show you what that looks like. But let me get to the next slide, because you can kind of see it from the slides. Am I not pointing it in the right direction? Okay. So this kind of goes through everything that we did. We created the model of Memphis. They had the bridge. They had Amazon. They had Walmart. They had a little bit of any type, whatever they decided they wanted to investigate. I said, okay, go for it. And I had to learn a lot with them. This is what the code looked like for what you just seen, the bot actually going around the city. So that's what the student coded himself. And I'm okay with the color sequencing, which is what you're going to do in just a minute. But the actual coding is something that I'm having to learn with them. And what I found was it doesn't take any time, and the kids will know more than you do. And let me back up too. That's also on Ozoblockly, and that is the app. So there's two different ways you can use the Ozobot. If you don't know, you can do line sequencing. That's without a device, or these are the newer model of the Ozobot. This is actually the Evo, and they have Bluetooth enabled, so you can have screen or no screen. So most of the time, I think most people probably prefer to start with the line sequencing and then progress to the app. So this is, if you can tell, you can see the bot is flashing green. He had the bot drive up to our park in Memphis. Memphis people, that's Tom Lee Park. And he made it look like the robot was actually reading the problem, and it's flashing green. That's like a big picture of the whole city, and we have a video, but I don't know why it's just not working. So maybe we'll be able to come back to that at the end. We had Amazon. This is our landfill, Tom Lee Park, the old and the new Memphis Bridge, and then the other businesses behind it. If you look in the background, you can even see some artwork. So it's really cool because they were all allowed to just pull in whatever their gift was or whatever interested them. And that's some more art. And they had LED lights on the bridge. I don't know if you can see that, right? Okay, so now let's get to the Ozobot. Before we get started, I've already kind of shared with you that, well, we can't have any liquid around the Ozobots or any type of food. If you are able to open the box on the top, there you go. Now you'll need to, when you pick it up, like this, there's a little button here, and if you'll push down lightly, it'll eject the bot. And while you're doing that, I'm going to talk to you really quick about what is an Ozobot. An Ozobot is a robotic platform that teaches basic coding skills. If you'll open the door, and then there's a little sliding plastic piece. Yeah. Okay. And then you'll have to pull the bottom piece out and push down lightly on the top. We'll give everybody just another few seconds to get the bots ejected. And if you would, pick up the bot so I can quickly talk to you about the hardware so that we can get into the really fun part. Okay, so if you don't mind, I'm going to use yours real quick. All right, so if you would, pick up the bot and notice there is a power button. It's kind of difficult to see. It's a circular button on the side. If you touch it, it'll come on. I'll turn it off and let you turn it back on yourself. All right, so that's the power button. If you would turn the bot over, look on the bottom. If you have it on, you'll see there is a strip of lights. That's the light sensor. Aha, you figured out the proximity already. So there's two proximity sensors. There's two in the front and two in the back, and then you have the light sensors underneath. That enables the bot to either follow the line sequencing or to be enabled via Bluetooth. All right, before we do anything, open the smaller box. You have two little boxes on the inside. The one that says color code, that's your marker. You can move that to the side. Open up the experience pack, and it's on the top. You should see a calibration dot. It's a big black circle. If you don't have one, no worries. We'll just draw it. Yeah, that's the calibration dot. I don't think this one has one. We'll grab another one. Here you go. Okay, so with the calibration dot, real quick, if you would turn your bots off, because in order for them to function properly, they have to be calibrated. I started to say calculated. That's a math person to me. All right, so in order to calibrate it, you're going to pick the bot up. You'll turn the power button on and hold the on button for 2 seconds. 1001, 1002. Then you set it on top of the black calibration dot. It will spin, it should, and flash green when it's calibrated. If it does not cooperate, well, you turn it off and try again. Turn yours off and try again. You may want to move it off of any, yes. Okay, has anybody got it calibrated? I see a green flashing light. Good job. It should be green and flashing when it's calibrated. Oh, you're already cheating. Did it calibrate? Okay, you're good. You're ahead of the game then. Okay, so basically what you've just been exposed to is nothing more than teaching children the hardware components. Not that hard, right? So you know how to power it on and off. You know how to calibrate it. You've also been given a color code sheet on your table, or there is one in the box, the one that you have in your hand. And it basically is a couple of different colors that gives the bot the functions that you want it to do. Whether you want it to turn right, turn left, spin around, back walk, it does all kinds of really cool things. And they've already tested it. Okay, so she's got the reference sheet, so you know the proximity and the color codes. I've also in the slide, and I believe that there's a way to share this with you all at the very end. This is the pacing guide through Ozobot. If you do end up using them, or your school purchases, or you use the free resource that I'm going to give you, this pacing guide is a lifesaver, y'all. If you go through it, you can literally go from K through 12. You can start with basic knowledge, or if you've got kids that have some experience, and you can just build. It's got the video, it's got the worksheets, everything that's on the table. That's where I pulled it from. So that's a great resource. What we're about to embark on now, so that you get a little experience with Ozobots and how much fun they can be, we're going to do a practice sheet with you first, where you're going to get an introduction to the color codes and how to draw those line sequences and get the bot to do what you want it to do. And then we're going to have a race, okay? That's why everybody's at a table. Before we start the race, let me show you what not to do. All right, if you look up here, you notice that the codes, if it has a white line in between it, if they're not completely connected, it will not follow. It won't do what you want it to do. If they overlap, if they're too dark. And what I found was that if you measure it, the line sequence has to be 1/4 of an inch for it to really accurately read it. You have the reference sheet. This is the reference sheet. Most people should have it on the table, and there's a smaller one inside the box. Okay, so before we start, me and my partner here, Miss Williams, we had a race of our own in the classroom just to test it out. You know, we're science teacher. I'm a science teacher. She's STEM, so we had to test it out. And we wanted to see how long it was going to take us to do this so that we could iron out our time with you guys. And what I found was she was faster than me. So I recorded her so that you will have these tricks. So when it's time to start, we'll skip to how do you do it quickly and effectively. So this is the last video, I promise.
And I didn't know that we were going to be showing this video to you, so.
It's not the best quality, but you get the idea, okay? So if you'll watch her, so when it's time to start racing, check out her techniques, and it'll really, really help you. Uh-oh. So I'll have to, I think we have a little technical.
It should work. It was recorded with the iPhone, so it should be fine. No?
Okay, it's not doing it. All right, so Miss Williams.
Okay, I'll just explain.
All right, if you would look at the sheet that you've been given, it says Intro to Color Code 02. And then take out the 4 markers. There's some already in the box, probably.
They're in the box. We just brought extra, but you can use the one from the box, and if you need extra set, it should be on the table.
The ones that came with the Ozobots are actually slightly slanted, and you'll see that that does help.
With the direction. So if you need one, if you prefer this, I can give this one to someone. You need an extra set. Okay.
Okay, so what we found in the video that, for whatever reason, isn't functioning was that what Miss Williams did and I didn't do, she took the caps off and she did all the black lines at one time, then she did all the little red at one time, then the green, then the blue. And she beat me by 2 minutes, I think.
So I only touched the marker one time. I only touch each marker one time as a strategy.
So we were gonna model that for you guys, but because the video is not functioning properly, right now I want you to take however you want to do it, it's fine, but her method works the best. So where you see, if you'll look at the codes at the bottom, it kind of gives you an idea. It'll say R for red, B for blue, of course. So go through and fill in the lines. Make sure that they're thick and that you stop wherever it gives you another color. Like number 1, if you'll go down to the bottom and look at the sequence for 1.
So this has to be black.
Yes,
Any questions?
good question.
Yep. And most of it is going to be.
So
used
she
with-
just asked a great question. She said this has to be black, all through here. And then the numbers, if you'll find the number, like number 6 is a nitro boost. That's blue, green, red. And just fill in those sequences. You want to start a timer? Okay, we're okay. Okay, we're only gonna have about 1 more minute for the practice.
Oh, I was looking for yours.
Give me your markers since they're slanted.
Yes. Okay, the black line needs to go all the way around. They've got it here and it's functioning. Pay attention to what the bot's doing when it goes over those color sequences. What color does it flash when it goes over those colors? Does it speed up? Does it slow down? They've gotten it. Okay, we're gonna give about 30 more seconds. So we have a second team that's completely done.
Dang, they're fast.
They didn't answer cell phones like we did.
I don't want to hear you laugh.
Pay close attention to the codes and what happens when they go over the different types of speed. Yes. It's okay if you didn't. It's no worries. Just. That's okay. Let's see, you can put a black here. And you just switch that one for that. If you make a mistake, it's okay. Just go in and find a different sequence that correlates with 1, 2, 3, 4, 5, or 6. Okay, so we should be about done with the practice part. And if you're not, it's okay. You're fixing to get more practice. Also in your box, you have color references for direction. So you can also direct the robot to either turn left or right, and that's fixing to be important.
I didn't do either, so that's okay.
Okay, so now it's time for the challenge. I know you're having fun, but it's fixing to get even better. Are you ready? I know.
Okay, I'm done. I don't know if she's got the Ozobot.
Oh, you did it. That's great. And if you think the adults are engaged, wait till you do this with students. They absolutely love it. We had a faculty meeting where we used this for PD, and everyone was ecstatic. Okay, so now, if you would, turn your bot off. I know you don't want to do that, but just for a second. Right, everyone turn your bot off.
I think my body's broken.
And you want to make kind of a clear space. All you'll need now are the markers, your color reference code sheet, a ruler, there you go. All right. So if you can try to make it as clear as you can on your table. I know you have a lot of things. We'll come around and assist. Okay, so now I'm fixing to present the challenge. Now it's time to race robots, right? Okay, here is your challenge. First of all, you have to draw a distance of 100 meters. I'm sorry, that's not supposed to say meters. No wonder you're looking at me crazy. That's supposed to say centimeters. His face told me, I was like, wait a minute, what does that say? Okay, all right, sorry. Centimeters, not meters. All right, so how far is your racetrack supposed to be?
100 centimeters.
Okay, and then it has to have 2 turns. It doesn't matter, left or right. It has to have a minimum of 2 different speeds. So you need 2 turns and 2 speeds. You can have more if you want. That's up to you. So you want to start similar to the way the codes are on the worksheet that you just completed.
Yeah, that's their fault.
Is everybody ready? Are we going to start the timer? Oh, yeah. Okay, this is an example that we did with the students. It doesn't have to be this complicated. He won only by default because the other teams did not have the correct distance. So don't be like him, but win, okay? I know everybody wants to win. So you need 100 centimeters, 2 turns, and 2 speeds. Are you ready? Are you ready? Who's going to win? Y'all are? Okay. All right, on your mark, get set, go.
Centimeters of black right now. Come on. 20 centimeters black.
Yes, ma'am. Just 20 centimeters?
Do 30 then. Come on. That's the length of it.
These markers are much better than any other.
Okay, stop. And now we need she said you turn, so we need a blue, a green, and a blue. No, wait a minute. That's speed, that'll work. A blue, a green, and a blue.
Don't forget to have 100 centimeters, not meters.
Centimeters, baby.
Right.
I do this every day with my 8
Oh,
in there and doesn't have anywhere to go. It's
Green, black,
You're doing really good over here by yourself.
red.
Can I ask a stupid question? So we're making it turn left. So does that mean this next line needs to be that one?
yes. Now, another way to make it turn left is just turn the black line itself.
That's what I thought.
Are y'all done? We have someone that's done already. Wow. Okay. Now we got to time them and see who has the fastest speed. Wow.
No, you went past, so it's gonna go down and then it's gonna go up. Yeah, I know. What to do. You should have started black and done that. Now it's gonna go here, you won't know what to do.
So you have 2 speeds. You have, right? 2 turns. What could you add to it to make it even better? Okay, there you go. That's improving. We're big on the design process. Oh, you did it. Got it. All alone, you did it.
You ready to time it?
Okay, we're going to have Mr. Cooley come around in time to see who has the fastest speed. We have a couple people already done. Great work.
Just a short distance.
I love it. It's 8 minutes and 17 seconds.
Red, green, blue.
8 seconds. Wait a minute.
Okay, you got to start over. I missed it.
Correction. 7 seconds. Less than 8 seconds. 7.75. Right. Is it? Yeah. That's okay. Add a little distance to it.
Now, should turn going up.
Get a wooden one. You could see that one better.
In black, not in green.
No,
This side.
nope, not quite. So you got 26 there, plus this, yep.
That's okay. Add a little more. If your distance comes up short, you can add a little bit more.
All right, now we wanna go. You ready? Blue,
I thought that was really fast.
put a red lid on
Okay.
it. Blue.
All right. We only have about a minute or so left. Does anybody else need to be timed? Mr. Cooley's ready. He's got his timer.
Red. That's your turn right there. Is there a gap? It's gonna follow the line.
So what happened? What's the problem? What caused it to stop?
You need black for the rest of it up.
If it's not smooth,
Well, it wasn't to that yet, though. So here, do this. Move our line this way.
that's what I would do.
I want to make it turn. Yeah.
You gotta turn here, you gotta turn here, don't take the turn. All right, measure how long we got, 100 centimeters.
We got almost 8, a little less than 18 seconds.
All right, stop. Measure, see how long we are. That's 30 to here. It's 30.
We only have a couple of minutes left.
35. Yeah, we're good, try it.
Where'd my black dot go?
I don't know. Stream on. He should. He's already recalibrated. Oh, yes. Have to be recalibrated.
if it's not doing what you want it to do, you want to make sure that those lines are completely connected.
I didn't actually measure it before, but that's 30 and 30 and 30. So 30 times 3 is 90. So
Here's just turbo. No, because the black's not connected. So you got the dot. Jeez. Told you. I'll get it. Cause you and your boot. Hey, sweetheart, don't step. He's underneath your foot. He come off.
He took a nosedive off the table.
Got it?
Get up with her boot.
Oh, they got, okay, 15.34 seconds. Good job. Have you got anybody to beat 15 seconds? It looks like their distance is accurate. It's a little longer.
oh, that's pretty cool. I like the color coding.
Okay, you got it now, huh? Good job. Good job.
You actually here, I think they have, is this one right there?
I did not know. Yeah, the nitro boost.
So we have 15, a little over 15 seconds here. Right here, yeah. 18? Okay. Anybody to beat 15 so far?
Where's 15?
Right over here. Okay. All right. So we are almost out of time. If you would, I would just like to share a little bit more information with you before I turn you loose. I hope you really enjoyed this. And more importantly, I hope that you can share this experience with your students, because with this new, the new shift to the standards for computer science, this is the easiest way that I've found to teach. Everything is right at your fingertips with the pacing guide, the videos, and it's very helpful. In addition, we also have found research that supports that the retention of learning for the students is a lot greater with the use of Ozobots. You can use this for math, science, social studies. There are hundreds of lessons on this website. So how do you get them? What if your school won't buy them? What if it takes forever to get them? Well, I found another way for you to get them for free. If you go to the ORISE website, I think I have it linked in here. ORISE, and I apologize for not saying it correctly, Oak Ridge Institute, I call it ORISE. If you go through one of their PD sessions, they actually pay your staff $50 for, I think, 2 hours. And once you complete any of their PD, and it's really good, y'all, I promise, we've done, I don't know how many. But once you do just one of the PD sessions, then you have access to their vault. And I rented all of these Ozobots and 3 3D printers. And they ship them to you, and then you just ship them back. It's all prepaid, no money involved. So check it out if you can. It's definitely worth it. You'll be very happy that you did. Does anybody have any questions before we dismiss? Oh, yeah, okay. Yeah, we got one more thing for you to do. That must not have worked out on the slide. Or they... If you don't mind, real quick, if you could do the survey, we sure would appreciate it. Again, this was just a really quick overview of what the Ozobots are and how much fun they can be. If you liked it, imagine what your students will do. They love it. And it gets them exposed to that terminology, the hardware, the algorithms, problem solving, creative thinking, because that's basically all coding is. Mm-hmm. Thank you all so much, and I hope you have a really good rest of your evening.